Let's start with an introduction of the DPU technology. Under what circumstances was it born?
Let's do some computer science archaeology. Fast network processing has always been important, and network packets that are sent over network cannot be used directly by applications. Network stack, which is the complex multi-layer software system that is part of the operating system, it requires quite a bit of CPU processing to expose really simple and intuitive network stream interface to applications. And so network packets come at a really high rate, and maintaining this really nice stream abstraction is increasingly difficult. And as many of modern computing architecture innovations, the idea of dedicated processing for input-output for I/O originated in IBM some 50 years ago. IBM mainframes are sort of the first example I know of where a whole programmable processor was dedicated to network processing. And it used to be called the I/O coprocessor and now a channel adapter. And so IBM needed this because I/O has always been tremendously important for IBM transactional workloads. But for commodity, it was not that bad. Up until about 25 years ago, it became quite clear that the CPU spans too many cycles on packet processing. And this observation led Intel to introduce a network processor on a network interface card, a device that could run simple programs and perform packet processing very, very efficiently, and much more efficiently than general purpose CPUs. But most importantly, unlike hardware controllers that could not be programmed, this device was programmable. And this is a big deal because a programmer could actually compile a piece of code written in a pretty weird and hard to program language, but still it was programmable, and it could load it to the device, and network packets got processed completely without involving the main CPU. And so unfortunately, it's been terribly difficult to program. Furthermore, it somewhat was too early for its time, it seems. General purpose CPUs at that time were still enjoying pretty good scaling rate. Most of the network processing applications were pretty efficient on CPUs themselves. But this started to change when the CPU scaling started to kind of stutter a bit. And a few years later, Microsoft came out with this project called Catapult, where Catapult was a device with FPGA with the NIC combined on the same card. And the idea turned out to be quite useful. So at about the same time, Israeli Mellanox company also came up with the idea of adding a programmable FPGA to a NIC as a what they call, or commonly referred to as, bump in the wire, where all network traffic goes through this NIC and goes through the FPGA processing. However, it was also pretty clear that FPGA is a special purpose programming architecture that is also not that easy to use. So in parallel, various vendors started to playing with the idea of putting some kind of general purpose programmable CPU, like ARM CPU, on the NIC as a system on chip. So basically being really tightly integrated with the network adapter. And Annapurna Labs was another Israeli startup that was later acquired by Amazon, identified the need for such devices with general purpose programming CPUs in data centers pretty early in the game. And now the Nitro device that is used in Amazon AWS on all their servers, this actually originated from this project. And then later on, Mellanox, as well as other vendors, started building these NICs already for production. So the most well-known Mellanox product is Bluefield NIC. Metronome and Cavium and other vendors came out with their own devices, with their own architectures that was also general purpose programmable. So this time it was also very clear where this technology fits, because the CPU scaling got really kind of not that great. It also got quite a bit of interest from academia, also in my own lab. And the ideas went well beyond the network stack acceleration. It also included server acceleration, virtualization stack, storage, application acceleration, and even GPU management, something that we also explored in my lab. So in the very end, the term DPU, as far as I can tell, was coined by NVIDIA after they acquired Mellanox. And the idea has been to accelerate a variety of network storage, virtualization, or what they call infrastructure tasks that data centers have nowadays. So far, everything of that sort have been running on CPU mostly, but now it was this DPU, data processing unit, or infrastructure processing unit in Intel parlance, that was basically taking over all of these workloads, freeing the main CPU.